Good morning, grade 11s. I know it's a while since I've been recording stuff and putting stuff on YouTube for you guys. It's been great to have you on Teams where we've had live sessions. But just to do a little bit of a revision on our mechanics from term 1. So I know the great thing with this section is we did do it in its entirety before any of this came up. But, you know, revision is always a good thing. So the first thing I want to remind you of is that what is on our information sheet? In physical science, that information sheet is so important. Really, even if you know the calculations or the equations, sometimes just remind yourself in case you put, I don't know, a big G instead of a small g, or put things the wrong way around, just to make doubly sure, because it's not pleasant when I have to take away simple marks. And remember, if you get an equation wrong, it's actually a principal error. So even if you get the sum right at the end, I cannot give you any marks for that section. So make sure, double check. So on the information sheet, we've got the equations of motion, as we learned them in grade 10. We've also got Newton's second law, F equals M, or F net equals MA. We know the gravitational equation, W equals mg. Then we've got Newton's law of universal gravitation. We've got the static friction and the kinetic friction equation. We also have a whole bunch of constants: acceleration of gravity on Earth, gravitational constants, the radius of the Earth, which we do sometimes need in Newton's law of universal gravitation, then Coulomb's constant, speed of light, charge on an electron, mass of an electron. Those aren't really relevant in this section, although a mass of an electron could be. Remember, the mass is 9,11 times 10 to the negative 31 kilograms. The charge is the negative 1,6 times 10 to the negative 19 coulombs. The mass of the Earth also sometimes used, and quite often with the mass and the radius of the Earth in a question, they actually put it there so you don't have to refer back to it. In this section, there are a couple that are not on the information sheet, a couple of things that are not on the information sheet. Firstly, your trigonometry is not on the information sheet. So please, I know this is like cross-subject breeding or whatever you want to call it, but you need to make sure you understand the basics rules of trigonometry. I always say, remember, silly old hags come and have tea or apples. So sine is opposite over hypotenuse. Remember, the hypotenuse is the one that's by opposite the 90 degrees, and the opposite would be the one that is the side that is opposite the known angle that you're working with. Cos would be equal to theta is equal to the adjacent over the hypotenuse, and tan theta would be the opposite over the adjacent. Then we also already taught you in science about the sine rule, which you could use for a non-90 degree triangle. And I know both the sine rule and the cosine rule will be coming up in maths shortly, and then we should make it even easier to use in science. But please don't forget, there is that whole cross-pollination, so you need to be able to do it. Then not on the information sheet is our straightforward average or constant velocity calculation, where the velocity is equal to the change in displacement over the change in time. I beg you here, please remember, constant velocity acceleration is 0. So as soon as it says the thing is accelerating, or you cannot use this equation, it is for a constant velocity, or seldomly but also usable for an average velocity. Components on a slope: the parallel component is equal to W sine theta. The perpendicular component is cos theta. Please don't get those the wrong way around. That's silly marks to lose. So please make sure parallel, sine, perpendicular, cos. Then Newton's third law, well, we know it's not really an equation that's usable, but obviously if I'm pushing on you with 3 newtons, you're pushing back on me with negative 3 newtons because the direction is opposite. And then gravitational acceleration on any planet, G is equal to gm over r squared, and we get that equation from using the W equals mg1 and the Newton's law of universal gravitation equation. Then a couple of things that we need to remember that come up quite often in graphs and in mechanics. The independent variable is the one on the x-axis that can be changed and can be controlled. The dependent variable is the value that is obtained on the y-axis when the independent variable is changed. So what that change in x causes my dependent variable to change, my change in the y-axis. The gradient is delta y over delta x. and whatever those two variables obviously are on a specific graph. And you can manipulate an equation to get what that gradient represents. A controlled variable is a scientific experimentation that is kept constant throughout the investigation. So when you talk about controlled, it's not that I control the change. If I control the change, that's independent. Control, it remains the same. So like, for example, when we did that experiment in Newton 2, it was the force, we changed the force, independent, which caused a change in acceleration, dependent, when the mass stayed the same. Mass was controlled. Delta, that's the Greek letter delta, and it means change. That's why when we say delta y over delta x, we're saying change in y over change in x. And you always get the change by taking the final or the second value minus the initial or the first value. As far as the definitions go, there are rather a lot in this section that we do need to know. But if you look on here, I've highlighted the important ones that they ask. The Newton's laws are very, very important. You need to make sure you know Newton 1, Newton 2, Newton 3, Newton's law of universal gravitation. I can tell you in your grade 11 end of year paper, at least 2 of them will come up, and they will come up again next year in June, in prelims, in finals. Get them into your head. If you're someone who struggles to remember definitions, write them out, stick them on your wall so that every time you walk past a certain point in your room, you can memorize them. And then other quite common ones are resultant force and then the different frictional ones. But I've highlighted them here, so have a look and highlight them in your definition book as well. I also just want to remind you that we need to make sure we remember this stuff to be examined in grade 12 as well. So if I just run through what the whole list is, we looked at forces as a vector with drawings and calculations, and then resultant forces. We looked at components of forces. We looked at equilibrium forces, types of forces, frictional forces. Under types of forces was quite an important one we looked at. Then we had Newton's first law of motion, Newton's second law of motion, Newton's third law of motion, and lastly we looked at Newton's law of universal gravitation and the gravitation that goes between that. So I'm going to end this video now, and I'm going to start straight away. You're going to see there is part 2 to this as well. I don't want to make them too long so that it's far easier to use on YouTube. So please follow the link now onto Chapter 2 or Section 2.